Welcome to the Architecture Corner. Today we're diving into something, well, surprisingly common, but also a bit tricky in building solid system. You know, that situation where your data changes, right? And then you also need to fire off events about those changes. Sounds straightforward, but there's often a hidden snag.
Oh, absolutely. That hidden snag is, it's about atomicity, or rather the lack of it.
Yeah.
You've got two key steps: saving your state, like in a database,
Yeah.
and then sending out an event, maybe to a mess at a pew. These usually aren't atomic together. So think about this. The payment goes through fine in your system, but the event, the notification, poof, it just doesn't get sent. And
Yeah.
suddenly you're left with this inconsistent state, which in event-driven systems, well, that can cause some real headaches later on.
Yeah. I can totally picture how that could mess things up fast. So basically, if your database and your message system are separate, there's just no built-in guarantee they'll both succeed or fail together. Sounds like you're just kind of hoping it works out.
Okay, so this sounds like a job for a specific pattern, right? The transactional outbox pattern. Before we get into the newer ways of doing it, how did people used to tackle this? What were the old
Well,
challenges?
that's a really good point because the pattern itself, the idea, is brilliant. But yeah, implementing it historically, it often meant quite a bit of, let's say, custom plumbing. You typically have like an outbox table in your database. Then you'd need some background job pulling that table, picking up events, sending them, marking them as sent. It was involved.
Yeah.
But the core idea, that's the genius part. You make saving the state and inserting the event into this outbox table part of the same database transaction. So atomic. If one part fails, the whole thing just rolls back, nothing half done. Thankfully, things have gotten a lot easier. The author of the material we looked at, Mario Bittencourt, points this out clearly. Okay, atomic commit to the database first. Got it. But easier how?
That sounds like the tricky part was always the getting the event out reliably. This is where it gets really interesting, right? With newer cloud services.
Exactly. This is where tools like AWS EventBridge Pipes really shine. They act like this super smart connector. It essentially grabs data from a source like a DynamoDB stream, which already captures database changes. Then it can transform that data, maybe clean it up, and then push it directly to a target like SQS or Kinesis.
Yeah.
And the kicker, it often does this with very little or sometimes even zero extra code you have to write and manage.
Zero code. How does that work? Like DynamoDB events can be pretty noisy, right? Lots of metadata. Right. So imagine scenario one. You want to publish the full domain event. Pipes can take that raw DynamoDB stream event, which has all this technical stuff wrapped around the actual data you changed, and using its built-in input transformation, it can just strip away all that extra stuff automatically. So what lands in your SQS queue is just the clean, pure domain event, your actual business data change. No need for you to write and deploy a Lambda function just to do that cleanup anymore. It's declarative, not imperative. Big shift.
Wow, okay. That is a huge simplification. Takes away a whole chunk of boilerplate code. But what if you don't actually need the entire event payload downstream? Sometimes you just want a smaller signal, right? Like a thin event, maybe just the ID of the thing that changed. Does pipe still help there, or are we back to writing custom logic?
Yeah, great question, because flexibility is key. Sometimes less is more. You just need that little signal. And yes, pipes can still handle that beautifully. For that thin event scenario,
Yeah.
just publishing an ID. For instance, you might use a tiny bit of Lambda code within the pipes enrichment step. But here's the thing. We're talking really minimal code, like no external dependencies. The whole package might be just over 1 kilobyte. And it runs super fast, maybe less than 2 milliseconds. So even when you need a little custom logic, EventBridge Pipes keeps it incredibly lightweight and simple, which translates directly into easier maintenance and lower costs for you, the developer.
Okay, that makes a lot of sense. It's not zero code, but it's minimal, targeted code solving just one tiny task.
Yeah.
So let's boil this down for everyone listening. What does this really mean for you? The transactional outbox pattern, it's pretty crucial for keeping things consistent, especially in these event-driven architectures. And the really good news is that tools like AWS EventBridge Pipes make putting it into practice way, way simpler. Less code, less hassle. It feels like a real game changer for these event flows.
Absolutely. It massively reduces that implementation complexity. But, a final thought here. While Pipes simplifies things a lot, it doesn't mean you can forget about monitoring and alerting. Things can still go wrong in distributed systems, right? Connections fail. Downstream services might be down. So having good observability in place is still absolutely essential. Preparation is key, always.
Excellent point. Build for resilience, always. Well, this has been super insightful. We definitely encourage you to explore this pattern and tools like EventBridge Pipes further. For more details and links related to today's discussion, definitely check out the description. And hey, why not subscribe for free to the Architecture Corner newsletter? You can find it at architecturecorner.substack.com. Thanks for tuning in.